Hello friends, I welcome you all to this session on C programming. So today, as I promised that I will be telling you more about will be solving more problems on 1D array. So I am solving two problems, very important. Dot product I have already discussed with you, but this time I will be discussing it from the point of view of tensor notations, that how to deal with it. So let's say I am having a vector A with components a0, a1, a2 and vector b with components b0, b1 and b2. I want to find out the dot product of these vectors. So in tensor form, these are written as a dot b is del ij ai bj, where del ij is nothing but Kronecker delta. Having a definition that when I becomes equal to j, so the value of del ij is 1, otherwise it will be 0. So let us write the program for this first. So as you all know that dot product is nothing but a scalar product. So let us take one dot variable and initialize it with 0. Now look very closely. How many indices are there? 2. So the number of indices is nothing but the representative of number of loops. So 2 indices are there. So 2 loops will be used. Okay. So for int I0, I less than 3, I plus plus, then for int j0, j less than 3, j plus plus, and inside what we have to do, we have to first pass the definition of this del ij. So this is going to be an integer. So let us define one integer delta, and here I will be assigning this dot as 0. So what is del? So if I and j are equal, then this delta is 1, otherwise this delta is 0. That is what the definition says. Look here, when I is equal to j, it is 1, otherwise 0. Then once this definition is known, then we have to sum up for I and j's. That means for you know how this loop is working. When I becomes 1, 0 let's say, so this will be j will be 0, 1 and 2. So it is 0, a0, b0 plus del 0, 1, a0, b1, then plus del 0, 2, a0, b2. Now j is over. Now this I will become 1. So it is del 1, 0, a1, b0 plus del 1, 1, a1, b1 plus del 1, 2, a1, b2. Then this will become 2. So this is del 2, 0, a0, sorry, a2, b0 plus del 2, 1, a2, b1 plus del 2, 2, a2, b2. So only those terms where I and j are same will remain, otherwise all will become 0. So this will become 0, this will become 0, this will become 0, this will remain intact, this will remain intact, this will become 0, this will become 0, this will become 0, this will remain intact. And here del ij will be having what value? 1. So that's why we have to add everything. So I have done this as dot 0. Once this is done, then what you do, you simply say dot assign dot plus ai times pj. That's it. Simple. And finally, you print this. Printf percentage d, or let me write this as dot product assign percentage d and comma. Here I will be simply printing dot. So if I run it now, so what is the problem? It is saying A undeclared. A undeclared. Oh, they are capital A and capital B. So capital A and capital B. So if I run it now, so the dot product is coming out as 6. Why? 1 times 1 is 1. 2 times minus 1 will be what? Minus 2, and 3 times 1 will be what? It is 3. So 3 plus 1 will be how much? It will be 4, and 4 minus 2. So 4 minus 2, it should come out as 2, but it is coming out as 6. Why? What mistake we have done? So if I becomes equal to j, then delta is 1, otherwise delta is 0. So we have missed this delta. We have missed this delta. So now if I run it, then it is coming out as 2. Look. So tensors are very elegant when it comes to this type of calculation. Now let us move to cross product. So the definition of cross product is like this. These are two vectors. Okay. Now the cross, in general, what we do, we use this determinant to find out the ijk value. Okay. And here in this case, in case of tensor, this tensor notation says A cross B. So the ith term will be epsilon ijk aj bk. Now here, if you look closely, j and k are the indices which are repeating. And always in case of repeating index, we have to add. So jj and kk are repeating, no problem. So ith term we will be getting. That's why we are writing it for ith. And this epsilon ijk is what we call as Levi-Civita and tensor, Levi-Civita tensor, and this is having a definition that when ijk are in cyclic permutation, so you will be getting 1. If they are in anti-cyclic permutation, so minus 1, and if I becomes j or j becomes k or k becomes I, then that is 0. What is cyclic permutation? So look here. So if I is 0, j is 1 and k is 2, this is the 1. So we are moving in a cycle. So epsilon ijk is 1. Likewise, 1, 2, 0 again cyclic, 2, 0, 1 again cyclic. So if ijk follow this pattern, then this is a cyclic order and that will be returning 1 for epsilon. Whereas if it is 0 to 1 or 2, 1, 0 or 1, 0, 2 like this, so the epsilon ijk will be minus 1. Okay. So now we are adding where? We are adding for I, for j and k to get I. So let me show this to you for I is equal to 1, 0 let's say. For I is equal to 0, if you copy this, let us copy this, paste it here. Oh, this is the problem. Let me write it. So A cross B, j term will be epsilon ijk A j b k. We are saying that this is repeating, so we have to add. So let us see how. So for I is equal to 0 and j is equal to 0, so this will be epsilon 0, 0, and k will be moving from 0, then 1, then 2. So it is this, then A j, that is 0, and b 1, then epsilon 0, so this will be 0 itself in the starting. 1, then it is A0 B1 plus epsilon 0 0 2, it is A0 B2, then plus epsilon. Now j k is exhausted, then this j will become 1. So it is 0 1 0 A1 B0 plus epsilon 0 1 1 A0, sorry, A1 B1 plus epsilon 0 1 2, and this will be A1 B2. So this is also over. Then comes J2. So this is epsilon 0 2 0 A2 B0, epsilon 0 2 1 A2 B1, epsilon 0 2 2 A2 B2. Now for I is equal to 0, we are summing up so many terms. But the beauty is that where I becomes j or j becomes k or k becomes I, that will become 0. So this will vanish, this term will vanish, this term will vanish. Here this will vanish, and we are left with this term. In the next line, this will vanish, this term will remain because I, j and k are different, and this will vanish. So we are left with epsilon 0, 1, 2, a1, b2 and epsilon 0, 2, 1, a2, b1. But 0, 1, 2 is cyclic, so it will become plus. So the output a1, b2, and here 0 to 1 is anticyclic, so it will become minus. So it is a2, b1. So the zeroth term of cross product will be nothing but a1, b2 minus a2, b1. You can confirm it from here. So it is a1, b2 minus a2, b1. So it is a1, b2 minus a2, b1. Okay, so in this way, for I is equal to 1, for I is equal to 2 as well. And here we are summing up for j and k. So j and k both will be summing up this. So let us try to write the program. So here, let me delete everything first because dot product is over. So now, let us make one inner sum as sum where we are summing for j and k and assign it 0. Doesn't matter, we will assign it 0 inside. Another one for that epsilon, let's say EPS. Okay. Now, how many indices do we have? 3. So, how many loops will be requiring? 3. I, j, k. Look here, I, j and k. So, for int I0, I less than 3, I plus plus. For int J0, J less than 3, J plus plus. And for int K0, K less than 3, K plus plus. What I have to do? First, I have to find out the epsilon. So, if I becomes 0, j, I and j are equal, or j and k are equal, or k and I are equal. If I becomes equal to j, or j becomes equal to k, or k becomes equal to I, then the value of EPS is going to be 0. Okay? Else, if, now this you should understand, if I becomes equal to 0 and j becomes equal to 1 and k becomes equal to 2, that is cyclic permutation, then it should be 1. So not only for this, for other combinations also, that is, or I becomes 1, j becomes 2 and k becomes 0, then also it will be 1. Or if I becomes equal to 2 and j becomes equal to 0 or k become equal to 1. So for all the cases, my epsilon will be nothing but 1. If this is also not true, then epsilon will going to be minus 1. Okay, once this is being done, then the task becomes easy. So where we have to sum the terms, where these terms have been summed up for I, j and k. So for j and k inside, we should sum this up. So just before j, we should have that value to be 0, where we are adding up everything. So what is that? That is sum. So here what we'll be doing, sum assigned 0, so that before starting of j, the sum should be 0. So inside this, I simply say sum assigned sum plus epsilon times, look, it is AJBK. So AJ times B, where it has gone, K. Done. So where we are keeping this sum? So this sum is for Cj, okay, Ci, sorry. So for 0th, it is 0, 1, for 1 and so on. So we have to keep this in ith loop, yes, Ci. So once this I, j and k are over, so where is my dot? I have to make one. So int, let's say C is the cross product array having 3 elements, let's say it is 0, sorry. And then here we will be doing what? Ci assigned what? This sum. That's it, friends. Done. Then simply we have to print it. So for int I0, I less than 3, I plus plus, then I have to print what? This percentage d, let's use comma, I have to what? C. That's it, simple. If I run it, it is saying some error. What is the error? Value required on left operand of assignment. Oh, this is equal. This is now equal. So the answer is 5, 2 and minus 3. So it is very simple. So what is the catch? If I reduce the size, the catch is how many indices are there? 3. So you should have 3 loops first. How many indices are repeating? 2 indices, that is j and k. Therefore, the sum should be on j and k. So just before j and k, we are writing sum as 0. And inside that j and k, in fact for k, we are defining epsilon. And once that has been done, we are updating sum. And finally, when j and k both are over, then we are updating the value of ci, or we are assigning ci that sum. Finally printing it. That's it. So friends, in this way you can use your one-dimensional array, and the concept which I have discussed with you is a bit different in the context of what people teach in graduation first year, but you should know this. This is a very important and very beautiful way of doing cross and dot product, that is using Einstein's notation. So in this lecture, till this point only. In the next lecture, we will be moving to two-dimensional arrays, and there we will be starting with matrices, because matrices are nothing but two-dimensional arrays. Okay, so in this lecture, till this point only. Thank you very much for watching it.